Hello and welcome to yet another 2x03 2G03 tutorial. If you'll just give me 1 second, I started recording without taking my pen out of the desk. So anyways, today we're going to be working on some taxation problems in a perfectly competitive market. So the question that I'm going to be solving for you today is this tax distortion question, and basically it's going to cover all the bases. We have a per unit tax, we have a like a sales tax, and we're going to look at tax revenues and consumer surpluses. So for the market for cigarettes in this made-up town, it's perfectly competitive. Quantity supplied equals 2 times the price. Quantity demanded equals 50 minus 5/100ths of the price. For what tax revenues, deadweight losses, market prices, and market quantities follow from A, the market outcome, B, a $1 per unit tax, and C, this 15% tax paid by consumers. Just like we had in Ontario until now, it's 13%, but 15% is a little nicer, so we'll work with that. So anyways, if you just pause the video, make your own attempt at solving these, and then I'll show you how I do it, and we'll go from there. Okay, so I'm going to take a new page, and we're going to start off with just the market outcome. So I guess this is part A. So anyways, anytime I like to do one of these problems, I like to when I first learn how to do them, I like to visualize what's happening. I guess I'll try to draw it better, but if you've been watching these, you know how bad it is to draw straight lines. So anyways, this is just the case where we have a supply and demand graph like you're used to seeing from first year. So we have QD equals 50 minus 0.05p. QS equals 2p. Okay, so from first year we remember that there's a market equilibrium when price equals quantity, or sorry, when the quantity supplied equals quantity demanded. Price equals quantity, wow, it's late. So we're going to set these two equations equal to each other. Okay, and we're going to solve them through for the price. And I actually haven't really prepared this one ahead of time, so I'm going to divide on my calculator as we go, and that'll make sure that I get the right answer. Okay, so our price is 24.39. And then to get the demand, we're just going to plug that into either our supply or demand functions. So it's probably easiest just to multiply it by 2, and we'll get that Q equals 48.78. So I know some of you guys are on tests like to write down every single decimal place that you see. That's really not necessary or correct. If you've taken any science, you'll know about significant figures, and I tend to just go with that. Okay, so that is the market outcome, right? A price of 24.39 and a quantity of 48.78. Alright, so I could plug these into my graph here, and maybe I will, because we might be referring back to it. 24.39. Okay. So I got to keep these numbers in tow for when I'm doing my deadweight losses. So anyways, next one is B. It's the flat tax, where you just get for every carton sold or every cigarette sold or whatever your units want to be, there's a tax of $1. Okay. So these are our same quantity and price. I guess I should label my axes here. Quantity, price, demand, and supply curves. And so we want to think about what happens when we introduce this $1 tax. Well, basically, if you were before willing to pay $50 for a pack of cigarettes, we assume that that doesn't change just because we introduced this tax. So the new demand curve is going to be sort of $1 below, $1 below the old one, right? So we're just shifting it down, and those two lines should be parallel. Maybe I'll do this just to sort of make it look like they are. Those two lines should be parallel, and this distance here is $1. Okay, so from that we get that PS equals something PD. Okay, so the first step when you're doing one of these taxation problems is to figure out just exactly what the distortion you're introducing is doing, right? So we no longer have one market price that prevails, right? There's a price seen by the sellers, there's a price seen by the demanders, okay? So for here with our price of seller, right, if we're thinking about this being sort of the new demand curve and this being the old demand curve, right, we need to come up with some comparison between the two. So I submit to you that the price for the sellers is the price of the demander minus 1, right, which sort of makes sense with that 1 unit vertical shift that I discussed earlier. Okay, so basically, if these were going to be the same price, right, then the demander would have to pay the $1 tax. So the price of the seller is the $1 difference in between the two. So we're considering PD to be sort of the original price from the demand curve, and now we've introduced this distortion. So now we have to rewrite our demand and supply functions. So we have now that QD equals 50 minus 0.05 PD. Okay, and we have that QS equals 2, and we want to do everything in terms of PD, right? So this is actually 2PS if I come back up here, and PS is PD minus 1. Okay, so if I multiply that through, it's just going to be 2PD minus 2. Okay, now we can use the same rules that we did before because we're working with one price, and we're going to still be working with one quantity. So 50 minus 0.05 PD equals 2 PD minus 2. Okay, so let's subtract both of these off. We'll make this 48, or sorry, 50, well, 52 equals 2 PD plus 0.05, so 2.05 PD. Okay, so now we've got this equation. We're going to divide through and find PD. Okay, so that's just 52 divided by 2.05. Alright, and I make PD to be 25.365853666, or 25.37. Okay, so that's our price of the demander. So we already have an equation for the price of the supplier, right? It's the price of the demander minus 1. So that means here that PS must equal 24.37. Okay, and now we just want to find a market quantity, right? And now since we've used PD and PS, we've got two different things, right? We can plug them both back into their original equations. So again, it's just simpler to multiply the price of the supplier, C's, by 2, and we get the quantity equals 48.74. Okay, now your good test is to plug this price of the demander into the quantity demanded equation and see if you get this same quantity. They should be equal. You can just take my word for it on this one, or I guess if you want to just check, you're welcome to do that. But anyways, now we want to look after the change in the consumer surplus, right? So we want to look for this deadweight loss here, which you're probably familiar, is the sort of little triangle that I've sort of drawn here. I'm going to fill it in if I can. It's basically the difference in between what the market outcome that we calculated in the first part, which is why I had you do it, did, and the difference when you put in the tax. That's your your loss of consumer and producer surplus is your deadweight loss, right? So if we've got the original quantity, right, if we think of this triangle and our original quantity was here at 48.78, and our new quantity is here at 48.74, right? And our original price, or sorry, we don't need our original price, we need the difference in between the two prices. So this would be PD, and this would be PS, right? So just drawing it out helps you picture the sort of the triangle that you need to calculate, right? And of course the area of a triangle is 1/2 base times height. So the height is actually this 48.78 less this 48.74. Okay, that's the height. And then the base is the difference in between PD and PS, right, which we already said was just 1, so it's sort of implied in this whole thing. So our deadweight loss is 0.02. You know, not a big deal, but it's only $1 per unit tax, not a big tax. So this is the calculation for deadweight loss. And then if we want to calculate the tax revenue, well, let's just think about this. Well, it's going to be the amount of the tax times the number sold, right? The amount of the tax is 1. The number sold is 48.74, therefore tax revenue, I'm just going to abbreviate TR, has to be 48.74. Okay, so that was the easy one. So just think about manipulating the market around a little bit. Right, if you want to impose this on the seller's end, right, you'd shift this original supply equation sort of up a little bit. So for any price, they would supply fewer units because they have to pay $1 in tax. So maybe I'll just show that here. All right, so we've got the original equilibrium, right? And then since I have to pay the tax, for any given price, I'm going to supply less quantity if you're just thinking about it intuitively. And that's your after-tax curve. Right? And then, you know, you've got the same sort of imposition of this tax here. And you do it basically the same way, and you'll get the same answer if you want to try it. So that's an easy way to check whether you get the right answer when you do that. Okay, so for part C, I'll erase this line here, which is the tax on the price, right? The value-added tax, or whatever you want to call it. We have to come up with something different, some different way of reflecting PS and PD. Okay, and I'm saying now that PD equals 1.15 PS, right? So the seller gets a price for something, someone puts that price on the shelf, and then when you go to the cash register, you pay an extra 15%. So 1.15 times PS. Okay? And this is going to work much the same way. So we have quantity demanded equals 50 minus 0.05, right? And instead of PD, we're going to put 1.15 PS, right? Because we've just substituted in so that we're working with one price for the market, and then QS is still going to be 2 PS. Okay? So same logic. Actually, I guess I should show you guys a graph of this first. Okay, so we've got the price for the suppliers. We've got the original demand curve, right? So the higher the price is, right, the more the tax is. And when the price is 0, the after-tax price is the same as the before-tax price. Right? So down here it's the same, and then we gradually work our way up until it's kind of a big deal. Right? So the level of the amount of the tax depends on what the price is, so it looks something like this. You can again use your imagination to make those straight lines. So we have 2PS equals 50 minus 0.05 times 1.115 PS. Okay, now just for simplicity, 1.15 times 0.05 is 0.575. Okay, so I can move these over. There should be a decimal place in there. Okay, and we'll divide those off. That can't be the right answer. 50 divided by 2.575. That's better. So PS is 19.41. Okay, and sorry, that's just not driving with. That's why it doesn't make sense. Okay, so when I multiplied these through, it's 0.0575. That's why I have one too many decimal places here. So my mistake. If that's why you weren't following, then you were right. Always check to make sure that your answer makes sense. Because if it doesn't, chances are there's a reason for that. I'm going to put my PS in front here. Okay, and now we should get something closer to 25, which is what I was expecting. Okay, so that's 24.30. Okay, and I've stated my answer in the right number of decimal places. So that's my price from the supplier, right? I can plug that into this supplier formula, and I'll get that the quantity is 48.60. Okay. Now, to check this, right, I want to make sure that it works out with my demand equation. So I'm going to take this and multiply it by 1.15, so I get PD. So the price of the demander is 27.95. And if I plug that price into the original, right, so if I take this 1.15 out and plug it back into the original, I get 48.60 back, right? So the market quantity works under both the under the tax structure, so I get the same quantity. Okay, and of course this isn't going to be to scale because 48.6 is not that much different from what we had before. But this is 27.95, and we already calculated that this was 24.3, which means the difference between these two is about 3.6. So our triangle that we're trying to calculate, right? This same one, the deadweight loss triangle, 1/2 times the 3.65, right, that we got from here, And the quantity restriction, which the market quantity, sorry, I'm going to have to go back up here. Market quantity was 48.78. This new quantity is 48.60, so the difference must be 0.18. So if I multiply that through, I get the deadweight loss here is 0.3285, which if I put in the right number of significant figures is 0.33. Okay, because it doesn't really, if you're valuing deadweight loss in terms of dollars, then it doesn't really make sense to have, if we're getting rid of the penny, it doesn't make sense to have 85 100ths of a cent. And last thing to do is calculate the tax revenue. Okay, so remember that there's still one market price. Okay, sorry, there's two market prices. There's one market quantity, and that market quantity is 48.6. Right, and the tax revenue collected on each pack or cigarette or whatever, right, is the difference in between the two prices, is the 3.65. Right, so I'm just multiplying the amount of the tax on each unit times the number of units. So my tax revenue is 177.39. I think I did this before and it should... Yes, okay, good. So that's your tax revenue, is the price times the quantity. And that's how you do this sort of problem. I think I've answered all the questions that I needed. Deadweight loss, market price, market quantity, tax revenue. Okay, so there's the answer to that question, and I hope you enjoyed learning how to do this.